Welcome back. This is the third and final lecture of week 8, and this happens to be the final lecture of this course on energy economics and policy. In this lecture, what we are going to do, it's a very short video where I would like you to motivate to think about the nexus between energy use and climate change. A very contemporary issue, a lot of research is being done in this area, a lot of opportunity is left. So, if you are interested in energy policy, it's worth visiting the area where you talk about the relationship between energy use, energy production, the impact on climate change mitigation, and the related policies. And this video is going to be majorly based on a book written by David Mackay in the year 2009, which is called Sustainable Energy Without the Hot Air. This book is freely available online. This is an open source book. You can search it on the Google and download all the chapters of the book, and this is a really interesting reading that motivates you to think about and to work on this area. So let us begin from this question: why energy policy? If you recapitulate whatever we discussed in this course, you will find that there are three underlying motivations that we have actually covered in order to understand why there should be energy policy, why energy policy needed at all. What are these motivations? The first one is that at the current stage, till date, most of our activities, the production as well as the consumption activities, are based on mostly, hugely fossil fuel. Renewable energy, the share of renewable energy has increased, but till date, what has been dominated is the use of fossil fuel. Now, what is the problem of using fossil fuel? The first problem arises from its inherent nature, that the stock of the fossil fuel is finite. So it's going to go over after a particular point of time. So if our production and consumption behavior are actually based primarily on fossil fuel, then what happens to that production and consumption behavior when the fossil fuels get over? So this is the first fundamental question. And in order to address this, we talked about several policies, starting from the energy efficiency policies, the demand side management policies. We also talked about the supply side policies, which are there to promote the renewable energy. So all these policies, they actually try to address the fact that the stock of fossil fuel is finite and it's going to be over after a point of time. The second motivation that comes into the picture is actually related to energy security. Now, it's not that everywhere fossil fuel will be over at same point of time. So if in my country, for example, this is just an example. Suppose my country, all the activities of my country are based on oil, and the stock of oil of this particular country gets over. So I have to rely on other countries where geologically still oil is available. So I can still continue my production and consumption activities, but for that I am making myself vulnerable by depending on a different country where everything can be affected by the geopolitical dynamics. So this is the second issue. Now, these issues are not much debated. In a sense, everybody accepts these issues, that you have to find an alternative of fossil fuel because it's going to be over. You also need to find out an alternative of fossil fuel in order to increase the energy security of a country. However, the recent motivation that comes into the picture, that is a little bit different from these two objectives. This is the climate change motivation. So in the book, David Mackay, in the motivation section, he writes it as the climate change motivation, which is very, very important. And what is climate change motivation? Fossil fuel burning leads to the emission of carbon dioxide gas, contributing to climate change. Let us see how. There are few gases which are called the greenhouse gases, for example, carbon dioxide, methane, chlorofluorocarbon and hydrofluorocarbon, etc., which are present in the lower atmosphere of the earth. Now, what do they do? The solar radiation actually powers the climate system. So the solar radiation actually comes to the earth. What does earth do with the solar radiation? It absorbs almost half of the radiation, which warms earth's surface, and half of it is being radiated back to the atmosphere. Now, because of the presence of these greenhouse gases in the atmosphere, some of this, the radiation which is reflected back actually stays within the lower atmosphere of the earth and further increasing the temperature of the earth's surface. So this lower atmosphere actually works like a jacket on the earth, and if the concentration of the greenhouse gas increases, then the jacket becomes heavier. Now, there is a certain temperature that is needed to prevail on the earth's surface in order to for the life to flourish. But if the mean temperature, if the average temperature on earth's surface goes up beyond a particular point, then that actually becomes unsustainable for the life to sustain, right? So it's important to have a particular concentration of greenhouse gas in the atmosphere, but it is also important to check the concentration to some sustainable level. Now, the problem is that when we burn too much of fossil fuel, leading to excess emission of carbon dioxide gases and excess concentration of carbon dioxide and other greenhouse gases in the atmosphere, leading to an increase of the average temperature of Earth's surface beyond the sustainable level. So that is called the problem of global warming. And if global warming takes place, this actually leads to other climatic events which are called climate change. So there can be change in the pattern of rainfall, there can be increase in the extreme weather events, and so on. And nowadays you see a lot of debate and a lot of discussion is going around this climate change area. And one of the major reasons, now you understand, is because of the burning of fossil fuel. So, in order to curb or in order to mitigate climate change, it's very important that you manage the use of fossil fuel, the burning of fossil fuel in a particular manner. This is the graph which actually shows how the temperature of the Earth's surface increased over the past century. So this is a very famous hockey stick plot which was published in 1999 by Mann, Bradley and Hughes, where they are showing that there was a drastic increase. So actually if I can show you here, so you see that there is a drastic increase in the global mean temperature since the beginning of the 20th century, following up almost kind of horizontal pattern. So there was short length increase and decrease in earth temperature. However, there is a sudden spike during the beginning of the 20th century, which actually shows no tendency to come down. So this is an evidence that the temperature of earth's surface is going up beyond a sustainable limit. If you go through the chapters published by Intergovernmental Panel on Climate Change, that is IPCC, you will see that using these trend, they have got a number of projections, a number of trajectories in which the earth's mean temperature can move, and they also discuss about the implications of the same. This is what actually shows that if you look at this diagram, so it says that in the beginning of 19th century there is a sudden increase, a spike in the increase in the earth temperature. Now we are trying to relate this increase in the global mean temperature with the increase in energy use. So if you look at this diagram, this has been taken from the David Mackey's book again. So as I have said, this is a free resource book which is available, and it's an excellent resource if you go through it. So what we can see here, he has plotted the energy use from 17th century to the beginning of 20th century to 20th century. So if you see that this is the point of rupture. This is 1769 where James Watt actually patented the steam engine, the modern steam engine, which fueled the industrial revolution in UK. Now, once the industrial revolution came, there's a lot of energy required for the production and consumption activities. And you see, suddenly there is an increase in the use of coal in the world. So this line is actually showing you the coal production in the world in a very interesting unit. So if you look at the unit, it doesn't say the tons of coal produced or tons of coal used. Here it's saying the gigaton of carbon dioxide per year. So it means the amount of coal, this red line shows the amount of carbon dioxide that was emitted by burning of the coal that was produced in a particular year. So this is the amount of coal that was produced is converted to the amount of carbon dioxide emission that it had potential to produce. So you see that the use of coal increased drastically since the beginning of the 19th century, since the beginning of the 20th century, and this actually overlaps with the spike or with the increase in the global mean temperature. Now, what we see in the next diagram, so in this panel, is even more interesting. So you see, I mean, for the 20th century, look at the 20th century, beginning of 20th century, the increase, I mean, the emission, the potential emission that was caused by the coal that was used at that point of time was only 1.2 gigaton of CO2 per year. Now, if you try to plot this much use of coal with respect to what is being used today, then it's very difficult to plot it in one single diagram. So in the second panel, what he has done is that this 1.2 gigaton of carbon dioxide per year has been plotted here. It has been scaled, the whole graph has been scaled down. So you see that it not only started in the beginning of the 20th century, but after that, the increase continued. So the use of coal increased greatly after 20th century. And not only coal, it was added by the use of world oil, which is represented by the blue line here. So the importance of these two diagrams, this particular diagram and this diagram, is that it shows that once after the Industrial Revolution, there was a huge increase in the use of energy for the production and consumption behavior undertaken by the human being. This not only has the implication towards the fact that we are using a lot of fossil fuel which has a finite stock, which may have implications for the energy security, but it also has the implication that this is contributing to the increase in global mean temperature beyond a sustainable level and leading to climate change. This diagram re-emphasizes the fact. So this is the diagram from the IPCC working group 3. I've given you the link. So this is also downloadable material. You can go to that and have a look at it. It shows that if we try to break up the total greenhouse gas emission by different sectors, 25% of greenhouse gas emission actually comes from electricity and heat production. And where does this electricity and heat go? It goes to several other sectors. So electricity and heat production is contributing 25% of it. Where do you get the other from? The others are coming from industry sector, who is again using energy. It's coming from the transport sector, where again the source is majorly the energy. So everywhere, whatever sector it is coming from, the source is the burning of fossil fuel, the burning of energy. Okay. Now the question is, why is it such a complex issue? Why is it so problematic to have a policy which can, moderate the or which can actually guide the energy use in order to curb climate change? Because the moment the concept of climate change comes into the picture, the things become very messy. You can't have only domestic policies in order to to go for carbon to emission mitigation or have a sustainable solution for climate change. The question is, why is so? Before we go into the discussion why is it so, we have to understand the concept of externality. Now, what is externality? It is basically a concept where my action affects your ability to act. It can be positive, it can be negative. So the economic literature, the first mention of externality comes in 1920, where the A.C. Pigou, he was writing about a smoke emitting factory which was emitting smoke, and it was causing negative externality, health effect, the productivity effect for the nearby business and the residents. So the activity by the industry was actually impacting in a negative manner to the business and the residents nearby. Okay. Now, this is externality. Now, how can you solve this problem? You can always ask the industry to pay a compensation to the business and the residents nearby. This is one process to do about it. But why this compensation process doesn't really work when we talk about global warming? The problem is that the problem actually lies in the characteristic of these greenhouse gases. Now, what are the characteristics of these greenhouse gases? Two fundamental characteristics are that first, it spreads relatively evenly in the atmosphere. This is one thing. And the second thing is that once emitted, they are going to stay for a long period of time in the atmosphere. So, what are the implications of that? So, when I say that they are actually going to be relatively evenly spread out, it means irrespective of the source of emission, the impact will be on everybody. So, irrespective of the source of emission, generally this greenhouse gas will increase the concentration, their concentration in the lower atmosphere of the earth, and therefore the more heat energy will be trapped and the global mean temperature will increase. This is one issue, and therefore the externality that is being there, there's obviously an externality. So if I pollute, if I am the country A is the source of emission, then the impact will be felt everywhere, all over the world. So for the entire world, this is a negative externality caused by the action of country A. Now, the problem is that if the externality is transboundary in nature, it also means that if country A mitigates the emission of carbon dioxide, the positive effect will also be felt all over the world. So, there is a lot of debate who should mitigate, because it doesn't matter who mitigates, the effect is going to be felt all over the world. So this is one problem. So here I have given the example. So the characteristic of the greenhouse gases with respect of the spreading is different from the local pollutants like SOx, NOx or particulate matter. When we talk about this local pollution, for example, when we talk about vehicular pollution, then the national government or the local government can have the policies to tackle this problem, because this is not a transboundary problem. Wherever it is being emitted, it's going to stay in the close proximity, but that is not the case of greenhouse gas emission. So if you think about reduction in greenhouse gas emission, then probably all the countries need to have a talk together, and therefore you see a lot of global conversation going on around the topic of climate change mitigation. The second problem is that, as I said, that once emitted, these greenhouse gases are going to stay in the atmosphere for very long period of time. What is the length of that? For example, carbon dioxide is going to stay for 100 years. As a result, if my generation's activity, my generation's production and consumption behavior is the cause behind the emission of carbon dioxide, the effect will be felt not only by my generation but also by the generations to come. Now, this is again problematic because it also means if you mitigate today, the benefit is going to be accrued in future generation. So your action towards mitigation depends on what is your time preference. How do you discount the future generation? How do you prefer the future generation? So this transboundary nature of externality and the intergenerational externality caused by these greenhouse gases which are being emitted because of burning of fossil fuel is actually causing a lot of kind of complexity in the policy formulation. Now, here, when I say that the greenhouse gases are emitted, CO2 is emitted by the burning of fossil fuel, it doesn't mean that burning of fossil fuel is the only source of CO2 emission. There are natural processes as well, and there are natural processes of assimilation as well. So we come to the question, because the policy is difficult, so we come to the question, who should mitigate, right? So if I mitigate, everybody is going to be benefited from that. However, mitigation is expensive, so some money has to go there. Secondly, if I mitigate today, then the impact is going to be felt tomorrow as well. So the question comes, who should mitigate? And here again, this example I've taken from David Mackey's book, and I'm giving you the numbers from a little, a little backdated number, but just to, in order to be able to explain the figures, I will stick to these numbers of 2000. So in the year 2000, the total CO2. So here one thing. Okay, so here if you look at the unit, it's called the gigaton of CO2e. CO2e means carbon dioxide equivalent. So this is the total greenhouse gas emission expressed in terms of equivalence of carbon dioxide. Okay. So in the year 2000, if you look at the bottom diagram here, in the year 2000, the total greenhouse gas emission of the world was 34 gigaton of CO2 equivalent. 34 gigaton of CO2 equivalent, and total population was 6 billion. Now, if I divide this 34 gigaton of CO2 equivalent by 6 billion, then the sort of per head entitlement of greenhouse gas emission, or per head greenhouse gas emission, we found that this is 5.5 ton. Now the question is that, is it the case that everybody is producing 5.5 ton of carbon dioxide equivalent? The answer is no. There are some countries where per capita emission is much higher than 5.5 ton of CO2 equivalent. There are many countries from where it's much lower, and therefore what he does is that he divides the 34 gigaton of CO2 equivalent across countries depending on their per capita emission. So if you look at the per capita emission figure, this is, you see the tallest bar, this is coming from this is not the tallest bar, but this is the first bar actually, this is coming from USA. The second one is from Australia with the tallest bar, and then you have Canada, Ireland, and so on. Here you have South Africa also have a little higher. So you see, this is 5, right? So this is 5. You see, there are many countries for which the per capita emission is much higher than 5 ton per year, and there are many countries, for example, like China also below 5 ton per capita, and India and many other countries here, Nigeria, Bangladesh, if you can see, even Thailand, here you see Egypt is close to 5, and then Egypt is much less than 5. So there are countries whose emission is much less than the world average. There are countries whose emission is much greater than the world average. This is one thing. That so the contribution of per capita emission to the transboundary pollution is different, that is coming from different countries. This is one point. The second point is that if you look at the historical emission, so these developed countries followed by industrial revolution, they started using this energy and started emitting a lot of carbon dioxide since the beginning of 20th century. Okay, since the beginning of 20th century. However, the developing countries joined much later in the league. So if you look at the historical burden, and this is one of the very popular terminology in the context of climate change policies, if you look at the historical contribution to climate change, the developed countries are far ahead with respect to that. And therefore, one argument comes in the form that because it's largely the historical responsibility of the developed countries, they should clean up the mess, right? So they should take more actions towards mitigation, which is partly, of course, true, but we also need to understand the fact that if countries like India, whose contribution to climate change today is not much high, it will become much higher tomorrow. It's also good for them to take the climate change mitigation measures. Why? Because the impact of climate change is going to be felt all over the world, and these developing countries are going with less infrastructure, less healthcare structure. They are going to face more trouble when the climate change comes real, right? So it's their prerogative as well to mitigate CO2 emission, to go for sustainable use of energy, and this also gives them certain co-benefits like energy efficiency or energy security and so on. So although the historical responsibility lies majorly with the developed nations, it's also important that the developing nations come and join a hand in order to mitigate the climate change and find out policies of sustainable energy use. So I'm going to stop here. This is the end of the course. I hope that the course was interesting to you, and in the last part of it, in this video particularly, if you are motivated to study more about the nexus between climate change and energy and climate change, there are many literature on that. There are many, this is the bustling field of research. You can always go through them. And so I'm going to stop here. This is the end of the course. If you have any queries, please feel free to write the questions on the discussion forum. You are always welcome to contact me if you have any further questions. So thank you very much for joining the course.